Okay, we're on number 15. We're trying to model tides, right? Tides are how the ocean, you can observe, comes in and gets higher because of the moon at certain points. The moon's gravity pulls on the water and makes it look higher at certain times of the day, and then it also makes it get lower at certain times of the day. You can clearly see this in Xiamen with the looking out when you cross the bridge between the island and the school. Some days you can see it's full of water and all the boats are floating, and other days you can see that it's completely empty, and you can see all those, what I assume are like clam fields with the rocks stacked up and all the boats are sitting on the ground, right? That's the tide coming in and coming out. That's actually maybe a decent idea for an IA, is exploring how can I model the tides of the Xiamen area right there, and you go out and collect data and try to figure out what function models that. It'd probably be a decent one if you're interested in it. So in this case, they're observing that the difference between high and low tides is 14 meters. The average time between high tides is about 12.4 hours. So if we think about what this graph would look like, right? So the water would be so if you think about here, this is high tide, low tide, and they're saying the average between those 2 points is 14 meters, meaning this distance between them is 14, which means the actual amplitude is going to be half of that, 7, right? They're saying that the average difference between high tides is about 12.4 hours, meaning after 12.4 hours, you would end up at a high tide between high tides, right? So that's actually your period, right? So we now know the amplitude is 7, the period is 12.4 hours. And they're saying we want to use this function to model the tide, where t is the number of hours after the first high tide. All right, so it says determine the values of A and B. We kind of already did that. A should be 7 because that's amplitude. B is equal to the period. So the period is always, remember, the period is always 360 over B. We know the period in this case is 12.4. So we got to ask, what is that B value, right? So it's 12.4 B equals 360. So B equals 360 over 12.4. Right, so we can check what that is over here. 360 divided by 12.4 is 29.03. So B is 29.03. Given that the high tide is 16.2 meters, find the value of D. Right, so what we have right now is we have H of T equals 7 cosine of 29.03 x, sorry, not x, but t, plus d. D is the midline. Where is that midline going to be, right? Is the midline at 0, or is the midline somewhere else? It says, given that the high tide is 16.2 meters, find the value of D. So high tide occurs up here at t equals 0. So if I plug in 0, 29 times 0 is just 0. Cosine of 0 is 1, but if you need to do that on here, you can. Cosine of 0 is 1. So we would have 7 times 1 plus D. And the high tide has a value of 16.2, so this is 16.2. So then D would be 16.2 minus 7. I don't know why I'm using a calculator for this. Anyway, 9.2. And so your D value is then 9.2. Right, so that D value is 9.2. Sketch a graph of H of T. We already almost have it here, but we should, do it a little bit better. So let's go ahead and just graph it, and we can be really good about it using our calculator. So we know this function is now 7 cosine 29.03 x plus 9.2. Let's check our window. Since the period is 12.4, we want to sketch a graph of h of t. We don't need to show that many periods of it. So let's say the farthest we go is, period is 29. I guess 70 is fine. That'll show us 2 cycles. Here, the y min is never going to be negative. You can't have negative tide. I guess you could if you think about it. Well, you can't have negative meters, so no. The y max is the highest the tide ever gets is 16.2, so let's go above that. Let's go to 18. All right, here's our graph. Sketch a graph of h of t. And so, oh, you know what? My window was wrong because the period's not 29. The period is 12.4 hours. So let's just do 25 because that's 2 cycles, right? That goes through twice, and that'll give us a little bit easier to see here. All right, so we're sketching a graph. Then we notice that this highest point, which we already knew, but that occurs at 16.2 meters. All right, so this is 16.2. We know our midline occurs at 9.2, right? So 9.2. Let me just redo this so I can actually write it. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ooh. That was a bad idea. Let's not do that. Let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. The midline occurs at 9.2. So 9.2 is going to be somewhere in here. I'm going to go ahead and draw it. All right, this is the line y equals 9.2. 16.2, 10, 12, 14, 16.2 is where it starts, right? Then we might want to know, oh yeah, I always graph this with the midline. So let me graph the midline in here just because it kind of helps us see it. We want to know, when it touches the midline, which again, you can just do second, trace, intersect. Oops, what did I do? I think I did something. Try it again. Okay, so it's just something going on. First curve, enter. Second curve, enter. I want to be over here. Oh, second curve, enter. Guess is here. Intersection at 3.1, 9.2. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 3, 3.1, 9.2, right? And then we want to know, well, when is it minimum tide? So we do second, trace, minimum. You got to be left bound, so I got to make sure my cursor is left of the minimum, enter. Make sure my cursor then right of the minimum, enter, and then guess. Get kind of close if you want, enter. So that, and so we can see at 6.2. So 3, 4, 5, 6. Come on, thing. 3, 4, 5, 6.2. 3, 4, 5, 6 is there, so a little bit past 6.2. We'll have a minimum of 2.2. Right, so that point right there is 6.2, 2.2. Right, so meaning that after 6.5 hours, the tide will be 2.2 meters. The height of the water will be 2.2 meters. And then you notice how that occurred 3.1 hours later. So if we go another 3.1 hours, that would be 9.3, right? So 6, 7, 8, 9.3 should put us back here. If we go another 3.1 hours, that would be 12 it should be one period, right? 12, which was in this case 12.4. Yeah, 12.4. 9, 10, 11, 12. 12.4. We should be back at 16.2, right? So here's what our function looks like, something like that. This part should be curvy. And that's one cycle, right? Next, it says find the height of the tide 8 hours after the first tide. That would just be going here, second, trace, value, 8. The height of the tide is 4.9 meters, right? So for part D, it's just 4.9 meters. All right. Your graph hopefully is nicer than mine because you can write on paper, which is nicer. Maybe remember to like label intercepts, right? So this is 0, 16.2. You should like label this important feature, maybe label the minimums, label important features of the graph, all right?